Now, see here, capital M is the mass, small m is the mass of the gas escaping per second with velocity v. MVT is the momentum of the gas in t seconds. So we take capital M plus small mvt equal to 0, then you take this on the other end minus, cross multiply, you get the answer. That is said to be the acceleration of the rocket. There is the acceleration of the rocket. That is said to be rocket propulsion. Next one. So now, we will go ahead with the next concept, that is banking of level road, motion of a car on the level road, and motion of the car on the level road and banked road. Okay, two concepts are there, and two derivations, very important derivations that we will do now. After those two derivations, we will start numericals. Okay, is it clear? No. Can I erase this? Girls.
No, sir.
No, sir. No, sir.
Okay. Now, circular motion. What is a circular motion? Definition of circular motion. What is circular motion? Motion of a body about a fixed point. Motion of a body about a fixed point. Motion of a body about a fixed point is said to be circular motion. Okay, motion of a body about a fixed point is said to be circular motion. Now, uniform circular motion, when a body completes equal rotations in equal intervals of time. Uniform circular motion. Uniform circular motion means if the body completes equal rotations in equal rotations in equal intervals of time. Equal rotations in equal intervals of time. That is said to be what? Uniform circular motion. Now, motion of a car on a level road. Motion of a car on a level road. So in this, what happens? Okay. Like suppose it is a roundabout. Okay. It's a roundabout and car is taking a turn on the roundabout. Okay. A car is taking turn on the roundabout. This is the center of the roundabout. Okay. The car is taking a turn on the roundabout in this way. So what happens? The centripetal acceleration is acting towards the center. Do you agree with this? The centripetal acceleration is acting towards the center. You know that whole diagram, right? When I was teaching motion in a plane, I have discussed about the linear acceleration, centripetal acceleration, and angular acceleration. Do you remember that?
Yes, sir.
Yes.
Yeah.
Yes, sir.
Centripetal acceleration is what? When the body is moving in uniform circular motion. When the body is moving in uniform circular motion, what happens? The acceleration is towards the center. That is centripetal acceleration. Okay. So that is AC. So this is said to be A is equal to mv. So here we have velocity. V is the velocity. So this is the center. R is the radius. V is the velocity with which the body is moving. Okay. So we have the formula A equal to what? V square by R. That is centripetal acceleration. Now here, when you see carefully about this particular concept, so when the car is moving, suppose when the car is moving, suppose this is the center. So acceleration, centripetal acceleration is acting towards the center. Now, how is the kinetic friction? The kinetic friction is between the body and the surface, right? The body and the surface, between the tire and the wheel. It's a kinetic friction or rolling friction, whatever it is. It will be down in opposite direction, right? Is it not? When the car is coming towards you, the kinetic friction or rolling friction is acting backward. Is that clear? Is it clear?
Yes, sir.
Now, when the centripetal force is acting towards the center, centripetal force or centripetal acceleration, both are acting towards the center. When the body is taking a turn like this, acting towards the center, and there is a frictional force, whether it is kinetic friction or rolling friction, it is between the tire and the rod. Okay, in opposite direction, in backward, in this way, in the backward direction. There is one more friction, which is called maximum static friction or static friction, which is acting between the tire and the rod. What? In this direction. In this direction. There's a tire here. The tire is here. There's a friction between the tire and the wheel in the opposite direction. This force is balanced with this force while taking the turn. Once again, the centripetal force, which is acting from the body towards the center, should be exactly equal to the frictional force, which is acting in the opposite direction between the tire and the road in this direction. Then only the body can take a smooth turn. Understood now? Did you understand this, all of you?
Yes, sir.
Yes or no? Once again, see here. Suppose I'll just take one more example. Some book can explain them. Yeah, this is the thing. Suppose think that this is a car. This is a car which is coming towards you. Okay. So when it is taking a turn like this, when this car is taking a turn, the centripetal force is acting from the body towards the center. Here, this is the center, towards the center. Now there is a kinetic friction between the car and the and
the road.
And the road.
The wheel.
And the road. That is kinetic friction or rolling friction. It is in the opposite direction. If it is coming towards you, then the friction force is acting backward. There is one more friction which is acting this way. This way. Between the tire and the road, this way. Okay, in the opposite direction of the centripetal force. That is frictional force. Okay, that is frictional force. Understood, all of you? So there are two types of friction when there are, you can say 2 or 3 types of friction acting when the car is moving on the road. One is kinetic friction or rolling friction, or the second one is in this direction, the perpendicular direction. Okay, if both are equal, if centripetal force, and if the centripetal force and the frictional force, suppose this is the car, okay, this is the car and this is the wheel. So wheel. So what will happen now? Car and the wheel. Okay. So this mg is acting downwards. Okay, this mg is acting downwards. Normal reaction is acting upwards. Normal reaction is acting upwards. So what will happen now? Now, this centripetal force is acting like this. Okay? And this is the frictional force. Small f. Is it clear? Frictional force is acting in that direction. Now, what is centripetal force? What is centripetal force? Centripetal force is say FC. When a body is moving in circular motion, when a body is moving in circular motion, the force from the body towards the center. Force on the body towards the center. That is certainly what? Centripetal force. The force acting from the body. The force acting from the body to the center, towards the center. That's said to be centripetal force. Okay. That is said to be centripetal force. Now, what are the two forces now? See, in the free body diagram, we have two types of forces. Upward force and downward force. See here. So if you see about the vertical forces, N equal to mg, normal reaction equal to weight. And horizontal force, if you take, both should be equal. F equal to small f. Okay. But what is F? This is Fc. Fc is what? mv square by r. And small f is mu times of n. Mu times of n. So I'm just continuing these steps here. So mv square by r equal to what? Mu is equal to mg times of n. M and n will go away. V square is equal to mu times of mg. Mu times of mg. So m and n will go away. V square is equal to mu r g, and v is equal to square root of mu r g. So this is the formula for velocity. This is the formula for velocity. V is equal to square root of mu r g. This is the velocity which is the body is moving in the in the circular motion. Once again, when the body is moving in the circular motion, the force acting from the body towards the center is said to be centripetal force. Weight is acting downwards. Normal reaction is acting upwards. Centripetal force is acting towards the center. Small f is the frictional force. N equal to mg. Capital F is equal to small f. Mv square by r is equal to mu into n. And then n is equal to mg. M and m will go away. V square is equal to mu rg. V is equal to square root of mu rg. Okay.
So acceleration equal to v square by r. That is the acceleration of what? The centripetal force?
This is centripetal force. Mv square by r is the centripetal force. This is the frictional force. Mu times of n is the frictional force. So we are equating n is equal to what? Mg. M and m will go away. V square is equal to mu rg. V is equal to square root of mu rg. Understood now?
Why do we take it v square in acceleration?
See, in centripetal acceleration, we have three formulas, right? Centripetal acceleration. What is that? Mv square by r, or sorry, mv square by r, or r omega square. Remember? Or 4 pi square mu square r, or 4 pi square r by t square. Remember this one, four formulas. What we did in the
Yes, sir.
motion in a plane chapter, last part of motion in a plane. This equation, we can use any one of the formula, no problem. V square by r. So in the what is f? F equal to ma, right? M is there. A is this one, centripetal acceleration, v square by r. So we wrote mv square by r. Understood?
Yes, sir.
Okay, so mu times of n, just equate it, you'll get the velocity. This is the maximum velocity with which the car can take a turn on the roundabout. So mostly, what is the speed of the car on the roundabout? What is the speed to be maintained? What is the speed to be maintained when you are taking a turn on the roundabout? Any idea? Anyone? Anyone try this? When the car is taking a turn on the roundabout, what is the maximum speed with which it can take a turn? Or what is the speed on the roundabout to be maintained? Anyone? No one has idea?
Is it 20 to 30 kilometers?
Yeah, it is 30. It is 30 on the big roundabouts. If it's very small roundabouts, it's 20 or 10. Okay. So that is why on the roundabout, you're not supposed to go at very high speed. Okay. So otherwise the car can skid. Okay. The car can skid or it can be thrown outward. So most of the accidents, especially with the trucks, the oil trucks or the big trucks happen because of that only. So if the speed is more than that, then it will overturn, will skid. Understood? So the centripetal force is less than the frictional force. So that is the reason it will be thrown outwards. Okay. Copy this faster, then we can go ahead. And if there is any doubt, please tell me. This is see here. Once again, for the circular motion, what is a circular motion? Motion of a car about a motion of a car about a fixed point. That is said to be a circular motion. Uniform circular motion, if the body completes equal rotations in equal intervals of time, that is said to be uniform circular motion. Now, motion of a car on a level road, when the car is moving on a circular track, like on a roundabout. So it's a level road, not the angled one. So v is the velocity with which the car is moving. R is the radius of the roundabout. C is the center. A is the centripetal acceleration. Small a is the centripetal acceleration. Now, if you are drawing a free body diagram, so weight is acting downwards, normal reaction is acting upwards. So Fc is what? Centripetal force. Small f is the frictional force. Centripetal force, which is acting from the body towards the center, and small f is the frictional force, which is acting from the tire towards outward of the car, outward of the road. Now, upward force equal to downward force. There is no vertical acceleration or vertical movement. So A equal to mg. Now there is no very horizontal moment this way and that way. So only the body is taking forward direction. So F is equal to capital F is equal to a small f. But capital F is what? Which is equal to mv square by r. What is capital F here? Centripetal force. What is centripetal force? When a body is moving in a circular motion, the force is acting from the body towards the center. from the body towards the center. That is said to be centripetal force. So the formula is F is equal to mv square by r. From where we got A? A we got from the last chapter, motion in a plane. That is v square by r or r omega square. These are the four formulas of centripetal acceleration. So just write here F is equal to mv square by r, which is equal to mu times of m. So just equate what is n? N is mg. Just equate that. M and m will go away. Then v square is equal to mu rg. Remove that square, we get v is equal to square root of mu rg. Understood now?
Yeah.
Clear? Is it clear?
Yes, sir.
Yeah. Okay. Done with this one?
Yes.
Yeah. Now, next concept is banking of force and angle of banking. Okay. Banking of force. That is what? Lifting of outer edge of the road. Lifting of outer edge of the road. So that the car can take a smooth turn. It can take a smooth turn. Okay. Like suppose you might have seen at the exit. When you are taking exit, like suppose from the highway to exit. So the car has to go up, right? So you might have seen the outer edge of the road is little tilted upwards. Did you notice this anytime? The outer edge of the road is little tilted upwards like this, maybe 5 to 10 degree angle. Anyone, did you notice this? Even in India also, on the whenever there is a turning or when the outer edge of the road is lifted a little upwards, like not too much, little small, it is lifted upwards like this. Even when the plane is taking a turn also, it will be like this. It will turn in this way. You might have noticed this one. In the railway track also. So suppose when there is a turn, the outer edge of the track is little lifted upwards. Did you notice this, anyone?
No, sir.
No, you didn't notice this? Okay. So
No, sir.
when you take a turn on the exits, next time, when you take a turn from the main road to exit, or from the highway to the exit, okay, you take the exit, then outer edge of the road is slightly tilted upwards. So you can notice this, okay? So when you take a turn, next time you notice this. So outer edge of the road is lifted upwards. So that is said to be like this part, outer edge of the road is lifted upwards. That is said to be angle of banking of force. What is angle of banking? Angle of banking is What is angle of banking? The angle with which the road is lifted upwards. The angle with which the road is lifted upwards. Okay, upwards. So that the vehicle can take a smooth turn. Okay, so that the vehicle can take a smooth turn. That is said to be what? Angle of banking. Okay, that's said to be angle of banking. Clear? Okay, so there is angle of banking. Next one, I will take this thing now. So next derivation is what? A motion of a car on a bank road. Is it clear, all of you? What is banking of road and angle of banking?
Yes, sir.
Yeah. Okay. Now next one. So we will draw the free body diagram. This is the free body diagram. So in the free body diagram, this is a car is moving on the road, on the bank road. This is the theta. Theta is the angle. M is the mass. So weight W equal to mg is acting downwards. See carefully. Weight is acting downwards, and this is the normal reaction. N is acting upwards. Now there are two components. See, this is horizontal component and this is vertical component. This is theta. So this can be written as mg cos theta, and this is mg sin theta. Mg cos theta and mg sin theta. Now, So there is a frictional force also. How is the frictional force? The frictional force is between the tire and the road. Again, I'm writing small f. Again, there are two components. What are the two components? Here we have f cos theta and f sin theta. So here, this is f cos theta, and this is f sin theta. F cos theta and f sin theta. F cos theta and f sin theta. Okay. So here we have again two components. What are they? N cos theta and n sin theta. N cos theta and n sin theta. This is theta. N cos theta and n sin theta. And there is a centripetal force. Okay. So n sin, this is n sin theta and the centripetal force or centripetal force or centrifugal force. This is outward. A equal to mv square by r. What is centrifugal force? When the force is acting from the body, from the center to the body. Centripetal force is from the body towards the center. Centrifugal force is from the center to the body. There is opposite reaction force. Okay, there is a reaction force. Now, so here, so I should have written the third law of motion also. What is Newton's third law of motion? What is Newton's third law of motion?
Every action is an equal and
Well,
opposite.
an opposite reaction.
So that is, for every action there is, an equal and opposite reaction. There is an equal and opposite reaction. Equal and opposite reaction, they act in pairs. And they act in pairs. Okay. So now what happens here? This is what, once again, weight is acting downwards. There are two components, mg cos theta, mg sin theta. The frictional force, f sin theta, f cos theta. N is the normal reaction, n cos theta, n sin theta. And this is centripetal force, mv square by r. Now we are going to write the resolve the components. How it is for vertical and horizontal. First, we'll start with vertical. Vertical, we have n cos theta. N cos theta equal to f sin theta plus mg. F cos theta plus f sin theta plus mg. That's first one. Second one, in horizontal one. In horizontal one, what is that? We have n sin theta plus f cos theta equal to mv square by r. N sin theta plus f cos theta equal to mv square by r. And here f is equal to what? Mu times of n. F is equal to mu times of n. Already you know, frictional force. Now we are going to substitute this value in both the equations. So once again, we will write here n cos theta equal to mu times of n sin theta plus mg. And here horizontal force n sin theta plus mu times of n cos theta equal to what? mv square by r. Okay, mv square by r. Those are the two equations we got now. Better, we will take the first equation and we'll take common. We'll take the first equation. Okay, we'll take the first equation and take the common. See here, let it be 1. Let it be equation number 2. So I'm writing from 1. From equation number 1, we write n cos theta minus mu times of n sin theta equal to mg. So we write here n is n into cos theta minus mu times of sin theta equal to mg. So now cross multiply that. Okay. Now, so here what happens? N is equal to mg by cos theta plus minus mu sin theta. Mg minus mu cos, n is equal to mg by cos theta minus mu sin theta. This is the one we got. Now let it be equation number 3. Now what we are going to do? Substitute equation 3 in equation 1. Sorry, equation 2. And write the heading here: motion of a car on a banked road. Motion of a car on a banked road. Banked road. The heading is motion of a car on a blank road. Okay. So once again from the beginning. So here,
So how do we get that n cos theta equal to f sin theta and mg?
once again, see here. Given from the, see here, n cos vertical force, upward force equal to 2 downward forces. So n cos theta equal to f sin theta plus mg. Is this clear? First one.
Yes, sir.
Second one, what is that? N sin theta plus f cos theta equal to mv square by r. Is that clear?
Yes, sir.
And f equal to mu times of n. Now wherever there is f, substitute mu times of n and solve it. Okay, solve both the equations, equation 1 and equation 2. Then after that, take the first equation and just take common. Bring this fellow on the left hand side. This positive will become negative. After that, take n common. After taking n common, cross multiply. You get this equation. Is it clear, all of you? Is that clear? No one is saying anything.
Yes, sir.
Now take the second equation, take n common from second equation. It will become from 2. I'm writing here from 2. From 2, what will happen? N is common. Sin theta plus mu cos theta equal to mb square by r. What is n? N equal to mg by cos theta minus mu sin theta into sin theta plus mu cos theta, which is equal to what? mb square by r, which is equal to mb square by r. Can I erase this one? Angle of banking thing. Yeah, can I erase this too?
Yes, sir.
Okay. Now here, so here you have mg, m and m will go away. M and m will go away. Now divide this by cos, sin, cos theta. Okay, divide numerator and denominator by cos theta. So what it will become now? G into sin by cos will become tan theta. Cos by cos will become 1. Cos by cos will become 1 minus mu tan theta. Equal to what? V square by r. So V square equal to what? R into G mu plus tan theta divided by 1 minus mu tan theta. So V is equal to what? Square root of R into G mu plus tan theta divided by 1 minus mu tan theta. This is the formula. If mu equal to 0 means there is no friction at all, then the formula is mu is equal to square root of Rg tan theta. If mu equal to 0, there is no friction, then this is the formula. Is it clear? Is it clear? This is 5 marker question. Very important question for the final exams or for any test. Okay. If there is no derivation, at least a numerical will come on this concept. Very, very important. Is it clear, all of you girls?